Hello and welcome everyone to this video of circles. So in this particular lecture, we are going to focus on the equation of tangent. How to write the equation of tangent and normal to a given circle in a particular condition would be the focus of this lecture. So let's get started. Let's say that this is a circle that we have, and at a given point x1, y1, I want to draw a tangent. Now, if somebody asks me what is the equation of this tangent, let's say this is 0, 0, and the equation of the circle is x square plus y square equals to a square. So we write the equation of the tangent. We can write it in two ways. I can write this as x1 plus y1 minus a square equals to 0. So that means this term remains as it is. And here I'm going to write this term I'm going to split out as x1, and this term I'm going to split out as y1. So this is very popular, and this equation is remembered as t equals to 0, where t is this. Now let's say that the parameter which is given is theta, and it is not in the form of Cartesian coordinates. So we know that the parametric form of a circle is given as a cos theta, comma a sin theta. So in that case, let us say that this point, instead of giving it as x1, y1, let us take it as a comma theta, a cos theta, comma a sin theta. Let's say that. Now that if that happens, let's put it in this, instead of x1 and y1, I'm going to put this point. Let's see what happens. So x into a cos theta plus y into a sin theta is equal to a square. This is what we get. Now throughout you can see that a gets cancelled, and so we get x cos theta plus y sin theta is equal to a. This is the equation of the tangent. So this is one format, this is the other format, and both can be used according to the given situations. Now the very fundamental idea that's going to help you out in solving the questions based on tangents is that when you consider any circle and the tangent associated to it, you must know that whatever is this line, this is a radius. So perpendicular distance from the center to this line is always a radius. That's a very fundamental idea that you have to remember while solving the questions. So I think we can definitely take some questions in a few minutes. And before that, I would like to introduce another concept over here. Let's say that instead of drawing the tangent at the given point, we now have to draw the tangent from the point outside. So let's say that this is a circle, and from the outside point, I need to draw these two tangents. Let's say these are the two tangents which are drawn. But this time this point is not given to us, this point is there with us. x1, y1 is this point. And from the outside point we have to now draw the tangents. Let us say that this line that we are considering, we can consider it as any y equals to mx plus c. And the equation of the circle is, of course, x square plus y square equals to a square. Now if I want to write this equation, we'll get two tangents, obviously. One slope would correspond to this tangent, the other slope would correspond to the other tangent. Now how to find the two slopes is a question here. So a very simple thing that we can do is, I can write distance of this point from this line is a radius, which is a. Now this point of course is 0, 0, and if I write 0, 0 over here, it's going to be root over of 1 plus m square. Now how this comes, let me just show you. So this is the line that we are considering, mx minus y plus c. In that, we have to put that point divided by root over of 1 plus m square. This is equal to the radius. That's what we have studied till now. But this x1, y1 over here is going to be, here it's this x1, y1 over here is 0, 0. because we are trying to find a distance of this line from this point and not this point. So 0, 0 when you put, you're going to get a as c by root over of 1 plus m square, which is the same condition of tangent c, which looks like this. So c is equal to plus minus a root 1 plus m square. That is what we get. That means the equation of the two tangents are going to be y equals to mx plus minus a root 1 plus m square. So I'm substituting this over here. Now plus is going to correspond probably to this tangent, minus is going to correspond to the other tangent. So it can be other way around also. But plus will correspond to one tangent, minus will correspond to the other tangent. So that is the format in which you can get the equation of the tangents if it is drawn from the point outside. That means this time the point of contact is not given to you, the outside point is given to you. So we can also have a situation as described in the last case, wherein instead of having origin as the center, I can have it as at any minus g comma f. So this is a circle, this is minus g comma minus f, and over here we are writing the tangent. So this is x1 comma y1. Now fundamentally what happens is the equation of the circle would change and it'll become this. So now whatever division, in whatever style we had written the last equation, a similar style is going to continue except for the g and f term. So this term is going to be divided as x1, this term is going to be divided as y1. This I can write now, we have to make half of this, g times x plus x1, f times y plus y1 plus c equals to 0. So this, in this particular case, this is the equation t equals to 0. Now there is some other way also to look at it. If you clearly see this figure, I can find out the slope of this normal. So this is a perpendicular, I can definitely find a slope of this. Slope of this is going to be y1 plus f divided by x1 plus g. Now this point is given to us, it is pretty easy to find out the equation of the tangent by using the slope point form of the line. So I can write y minus y1 equals to mt into x minus x1. So what we found is the slope of the normal. What we want right now is the slope of the tangent. So slope of the tangent is going to be negative reciprocal of the slope of the normal. That means the slope of the tangent is going to be minus of x1 plus g divided by y1 plus f. Using this as the concept now, I'm going to substitute over here and we can definitely find the equation of the tangent what we want. So let's solve a few good questions based on this so that you get a very clear idea of how to apply this concept. So this is one question now in front of us. Find the equation of tangents to this particular circle which are parallel to the line 4x plus 3y minus 5 equals to 0. So what are we going to do now? Very simple. This is a circle that we're talking about and this is the tangent. The one information that's given to us regarding this tangent is that the slope of this. So slope of this is going to be minus 4 by 3. How do I know that? Because this tangent is parallel to this line. So its slope and the slope of the line has to be same. Now this point over here is of course 3 comma minus 2, which you get to know from here. And if you look at the radius is going to be 9 plus 4 minus of minus 12, which is 5. So that's the radius. So I know the perpendicular distance now, that this is phi. Let me use this concept over here and now we can write the equation of the tangent. So let us say that the equation of the tangent is going to be 4x plus 3y plus k equals to 0, because the equation of this and this is going to be almost similar. with regards to the slope, except the value of k. So now we have to find the value of k. Now I know that this line is 4x plus 3y plus k is equal to 0. So distance of this line from the center has to be 5. Let's use this concept. So that means I'm going to write 4 into 3 plus 3 into minus 2 plus k divided by 5 is equal to 5. This is what we get. Now if we calculate, this is going to be 12 minus 6, which is 6. So mod of k plus 6 should be 25 is what we get. Now when you remove the mod, it's always a plus minus. So I can write k plus 6 is equal to plus minus 25. So for the first time, it's going to be 25 minus 6. That's going to be 19. And k, the other time, will be minus 31. So there can be two equations of the tangents that we're looking out for. One is definitely 4x plus 3y plus 19 equals to 0. The other one is 4x plus 3y minus 31 equals to 0. That is the equation of the tangents that we're looking out for. Let's take up another question. So it says that a circle x square plus y square equals to 5. So the equation of a circle is mentioned here. Has a tangent at the point 1, minus 2. So let's draw it. Let's say this is the circle and this is how it is. And this point is given to us as 1, minus 2. This point is 0, 0 and this radius is given as 5. That's the information that we have for now. Now this, it's root 5, sorry. This tangent is touching another circle. That also is given. So probably it is this circle that you are talking about. And this is the point of contact. So this is the point of contact that we have to find. Given that this is this circle, let's call this circle C1, let's call this circle C2. So this is what C2 is. So what is the center of this? The center is going to be 4, minus 3 and the radius of this is going to be 25 minus 20, which is root 5. Now this is the information that we have. We will use it as and when required. For now, I know that I can write the equation of this tangent. So we know that if there's a point of contact given, then we can definitely use this equation of the circle, x1 plus y1 equals to a square. Now over here, x1 and y1 is given to us, which is 1, minus 2. So let's put it over here, x plus y into minus 2 is equal to 5. That means this is the equation of the tangent. Now we have to find this point of contact. So that means somehow we should be able to link up the equation of this circle and this tangent and then solve them together. So one information that I get from here is this is 5 plus 2y. X is 5 plus 2y. Now what I can do is I can put this x over here in this equation and we'll try to find out what this gives. So 5 plus 2y the whole square plus y square minus 8 into 5 plus 2y plus 6 into y plus 20 equals to 0. Now clearly you can see that this is a quadratic in y. So if I expand, I'll get a quadratic. So let's expand it. I can see one thing for sure over here, that there will be 4y square coming out from here and this is y square. So this is 5y square. Now the next term that I'm going to write is of definitely y, which I know is 6y minus 16y. So there is 8 into 2, which is coming out as minus 16y plus 6y is minus 10y. And there will be 20y over here also, which is going to be 10y. This is what I'm getting. And then the final term is constant term, which I know is here it's going to be 25, here it's going to be 40, and there is 20. So this is minus 20, and finally what remains over here is minus 5. Finally what remains is 5. So the constant term is 5. This is equal to 0. So now we have to solve it. And what this gives is y square plus 2y plus 1 equals to 0. Now this is a perfect square. So that means y is equal to -1. That's what we achieve. Now once you get y equals to -1, we can definitely find x given this relation, and that comes out as 3. That means the point of contact is nothing but 3 comma -1. Now we have a situation wherein, let's say this is one circle which is given, the equation of which is given. Now this implies that 7 minus 1, 7 comma minus 1 is the center, the radius is 5, all this information we have. And tangents are drawn from 0 comma 0 to this circle. We have to find the slopes of the two tangents and also find the angle between them, theta. So if I want to find this, first of all, I can write the general equation of this tangent as y equals to mx. Now why I am writing y equals to mx? Because the constant over here is 0, simply because this is passing through the origin. And we know that any straight line which is passing through the origin, we can write the equation of the circle as y equals to mx. That's what I've done. Now, if I know that this is y equals to mx, the next thing that probably we need to find out is the equation of the tangent. And that is precisely finding m. So to do this, there is some information that we have. I know that this is that same line, y equals to mx, or precisely we can write it as y minus mx equals to 0. And this point is 7 comma minus 1. So this is the radius, and that according to this it is 5. So let's put up this equation and see what we're getting. So that's going to be 7. So in place of y, what will come is -1. In place of x, there will be 7 divided by root over of 1 plus m square. This is equal to 5. Now we have to see what m comes out from here. That's it. In order to achieve that, what we're going to do is, we're going to write the equation in a revised format. So even if I remove this mod, there will be plus minus. So to counter this, the best way is to square on both the sides. So if I square on both the sides now, the plus minus part will go, and this will be 49m square plus 1 minus 14m plus 14m, 25 into 1 plus m square. This is what we are getting. So this will be 24m square after solving plus 14m minus 24. This is what we are getting. Now if I solve this further, this will definitely be simplified. 12m square plus 7m minus 12 equals to 0. Now we need to factorize this. So the simple factorization which comes out is 12m square plus 16m minus 9m minus 12 equals to 0. So if the m comes out, 4m will come out. So this is 3m plus 4 inside, and this is going to be 3m plus 4 equals to 0. So m can be 3 by 4. This is m1, and the other slope that we have is minus 4 by 3. So we are able to find two slopes from here. That means the slope of one of the tangents is 3 by 4, the other one is minus 4 by 3. Now clearly we know that from our past knowledge of straight lines, if the format of the slope is something like this, that means they are perpendicular. So the angle between them is pi by 2, as m1 into m2 is giving you -1. Now this is a slightly different question. It's given to us that we have to find an equation of pair of tangents drawn from origin to this particular circle. So there is a concept. The concept says that if we have to write the equation of both the tangents which are drawn from a certain point to the circle, then we have to write it as S1 equals to t square. This is the format. Now what is S, what is S1, what is t square? So let's say this is a circle, and This is one tangent, and this is another tangent that we're drawing. Okay, this is another tangent that we're drawing. So this is x1, y1 from where you're drawing the tangents. And the circle, let's say, is x square plus y square equals to a square. Now this is nothing but s. If I write it in a slightly modified fashion, this equals to 0, this is s. S1 is what? If I put this point over here in this equation, that will become S1. And then t is the equation of the tangent. So t is nothing but x1 plus y1 minus a square equals to 0. This equation, that means of course in the entire thing, we are just writing the expressions. We are definitely not equating it to 0. Because if we equal to 0, then ultimately the equation won't make any sense. So S1 equals to t square. So I'm going to write this equation as x square plus y square minus a square into x1 square plus y1 square minus a square. So s and s1 are written now. This is s, this is s1, and t square is going to be x1 plus y1 minus a square, the whole square. This is the equation of the pair of tangents written together. Now over here in this, we have a similar kind of thing. But if I have to write the same format over here in this part, then it will be written in a slightly different way. Because we know that this is the equation of the circle now. So S for us will look like this: x square plus y square plus 20x plus 20y plus 20 equals, this is the expression. S1 is going to look like, we are putting 0 throughout x and y, we'll put 0, 0 because the point under consideration is the origin. You're drawing those tangents from 0, 0. So I'm going to put 0, 0 in all x and y. What will remain is only 20. And what is t square? So let's put that as well. So that is going to be x into 0 plus, if I put x into 0 plus y into 0 plus 10 into x plus 0 plus 10 into y plus 0 plus 20, the whole square. This is the ultimate expression that we will get. Now let's put it up in the expression form and try to get a final answer. So x squared plus y squared plus 20x plus 20y plus 20 into 20, because S1 is 20, and this is going to be 10x plus 10y plus 20, the whole square. Now clearly you can see that 10 is coming out of here. So definitely some expression will be simplified. If 10 is coming out of the square, it will come out as 100. And the equation will look like this: x square plus y square plus 20x plus 20y plus 20. Here what I do is I'll remove the 10 out. If I remove the 10 out, what will remain is this. And what will come out is 100. So 21s are 25s are. Now this will look like 5 times x plus y plus 2, the whole square. So now all that we have to do is expand on this side. X square plus y square plus 20x plus 20y plus 20. This will be like 5 times x square plus y square plus 4 plus 2xy plus 4x plus 4y. This is what we get. So this is a simple expansion of a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Clearly you can see that here I am going to have one term as 20x, one term will be 20y. You multiply and see, you will realize this fact. And so I can say that the x term will get vanished, y term will get vanished. Apart from that, 5 into 4 is 20, so the constant of 20 will also vanish. And what will remain over here is 4x square plus 4y square. And we are going to also have this term over here, which is the xy term, 5 into 2. This is what will remain. Now I can still simplify it. I can write it as 2x square plus 2y square plus 5xy equals to 0. This is the equation of the pair of tangents written together. So this will have both the tangents together in one single equation.